Now, there's a lot of this is a lot of stuff, the 750 gigatons of carbon in the atmosphere, and we see that the burning of fossil fuels adds 6 gigatons per year of carbon dioxide to the atmosphere, but photosynthesis is taking out 61 gigatons per year. Reforestation, that means planting more trees because you've cut down trees, takes out 0.5 gigatons, but deforestation releases 1.5 gigatons. Respiration, okay, that's breathing. Plants and animals both undergo respiration. That's 60 gigatons a year just due to respiration. Okay, 60 gigatons versus just the 6 for the burning of fossil fuels. So, every time we exhale, we're pumping carbon dioxide into the atmosphere, and which is 10 times more than the burning of the fossil fuels. So part of understanding the contribution or to this concept that we're building up to, which is climate change, which is we know that carbon dioxide can absorb infrared radiation that can emit the infrared radiation and serve to warm the atmosphere and the surface of the earth. So the question is, can really this relatively small amount compared to the 90 gigatons that's being emitted from the oceans really affect, the average global temperature? So we have to start looking at this more quantitatively, looking at these carbon dioxide emissions. All right, so here's a more detailed look at carbon dioxide emissions. This is breaking down just looking at the carbon dioxide emissions due to humans. Nothing to do with the natural, oceans and living things and dying things back and forth. But this is just, because of modern society, this is how many million metric tons of carbon dioxide is released into the atmosphere per year. That's what this graph is showing. So now we're looking at tons of carbon dioxide, not carbon. This is just looking at the amount of carbon dioxide that is being, pumped into the atmosphere. Over time, what you see is that it's gradually increasing from 1990 to 2005, gradually increasing in every sector except for industrial. All right, but the transportation, that's like from cars and trucks, residential, commercial, mostly power usage is what, from power plants, which emit carbon dioxide. And what you can see is, the industrial has come down, but everything else has gone up. And the part of the reason why the industrial is probably coming down is because the pressure from governments on businesses to try to limit their emissions. We'll talk about that a little bit later. But we can see clearly that over time, there's been an increase in carbon dioxide emissions due to human activity. So even though it's relatively small amount compared to the natural sources, there is a change in the carbon dioxide that's being emitted. And this is all in the U.S. Okay, this is U.S. All right. So we know that there's this big cycle, and we know that that human endeavors have caused more carbon dioxide to be spewed into the atmosphere. But what story does this data try to tell us? Well, what we know here is that the quantity of carbon released by human activity, that is deforestation and burning of fossil fuels, is about 6 to 8.2 gigatons per year. Now, about half of that is recycled into the oceans and the biosphere. It just dissolved in the water of the oceans. The biosphere would be taken up by plants. All right, but the other half remains in the atmosphere. So human activity is adding about 3.3 gigatons of carbon to the atmosphere per year. And the question is what will that do to the ecosystems of the world? Will it make a difference? That's what we're going to try to investigate for the rest of this chapter. All right, so as we try to understand this 3.3 gigatons of carbon added to the atmosphere per year, we want to be able to think quantitatively about amount of carbon versus the amount of carbon dioxide, so we can understand how the scientists think quantitatively about the amounts of carbon and the amounts of carbon dioxide, and how they can predict and put these measurements into their computer models to help them predict how much the global temperature may or may not change based on these carbon dioxide emissions. So we want to be able to think quantitatively to answer this question: what mass of carbon dioxide contains 3.3 gigatons of carbon? Now, before we attempt to answer this question, we need to go back and review some fundamentals, just some basic chemical fundamentals, so that we can answer this question. All right, and so some of you may have had a really strong background in these basic chemical fundamentals about molar mass and atomic mass and whatnot. And if you had, you may want to buzz through the next the next half of the lecture very quickly. But if you haven't, you may want to pay attention. If you can't answer this question real quick off the top of your head, well, not off the top of your head, but by a quick calculation, then you may want to take a little bit of time to go through and review some basic fundamentals of chemistry and quantitative chemistry.